All right, lab partner, welcome back. Part 3. We have the reaction 3. We're using 100 milliliters of HCl, 1 molar, which I've actually already taken and poured that into the styrofoam cup. Took the liberty of doing that already. The temperature of the acid is 24.4. I just had to make some more acid solution, and as a result, it's a little bit higher temperature because of when I was adding water to it, it releases, it's an exothermic reaction. So there's a little bit of heat in there. So a little bit higher than room temperature at this point. You can see these are getting, you can see that they're already kind of glisten. I just put these on here. They get wet pretty quick. So we need to get those into the cup. All right, so we have a mass of 4.19. Keeps fluctuating a little bit, but that's the average. All right, we'll put you down, and I'll be back. Hang on. I know, it's nothing personal. Nothing personal. Come on, get in there. Already being all sticky like. Alright, it's in there. This top goes on. And we start to mix. Alright, so I put the pellets in the acid solution. And we're getting a temperature rise. Let's move this over here. 31.0 at this point. So this is kind of a combination between the last two reactions. Reaction 1 was making a solution with water, and reaction 2 was a neutralization reaction. It's a combination. We're taking those pellets, we're putting them in acids, we're making a solution out of it. That was part 1, and we're also neutralizing, since it's sodium hydroxide pellets. And that's, you can see that temperature is really getting up there, isn't it? 42.0. Geez, it's fluctuating all over the place. I don't know what to do. So let's go ahead and keep mixing. I'm mixing this around. You can see how it's in there. Not quite dissolved, almost. And we'll get a final stabilizing temperature on that. It's going all over the place. So this is, so it's also a neutralization reaction at the same time. So it's doing both the reactions that we did previously at once, which kind of might explain why the temperature is going up so much more than it did in the first two. It's kind of like a combination of those two, right? So we get the higher temperature fluctuation with a combination of those two reactions. 48.6. We might have stabilized. We're very close to it. Yeah, looks like 48.6. Okay, we're calling it. 48.6 is the final highest temperature. The pellets are all gone. So let's record that. 48.6. 48.6 is our final temperature of the solution. That wraps up getting our data. And I'm going to get this all cleaned up here, and we'll come back and we'll talk about these two reactions individually. This reaction here, this is the overall reaction, and I was trying to explain that to you. That this is a particular reaction, this is a particular reaction. They have a little bit of a temperature change, and we combine these two, and then bam, we get this big temperature change. So as his law says, we can get the overall temperature, the overall heat released by this reaction by either doing this reaction or by doing each individual reaction and adding up their heats. So what should happen is the heat released by this reaction and the heat released by this reaction, the two partial reactions, should total the amount of heat released by the overall reaction. All right, I'll be back soon, lab partner, after I get this mess cleaned up.